Hello, students.
Yes, ma'am. Good morning.
Good morning, ma. Hello, students. So what we have discussed in previous class, ma?
Newton's forward interpolation, Newton's backward interpolation.
Very good, ma. In previous class, you have learned that the Newton's forward difference interpolation formula as well as Newton's backward difference interpolation formula when the given data is at equally spaced values of x. So when we use Newton's forward difference interpolation formula, ma, when we are using this formula, ma, anybody?
At the starting point.
Yeah, so this Newton's forward difference formula is used for interpolating near the beginning of the table of values. Is it right? That means it is useful for finding the polynomial interpolation or finding the functional values at any value of x, which is near the beginning of the tabular values. Similarly, Newton's backward difference interpolation formula is useful for finding the polynomial interpolation or functional values at any value of x, which is near the end of the table of values. Okay, at the beginning of the table of values, at the end of the table of values, we know that how to find the functional value or polynomial interpolation. Suppose at the near the middle of the table of values, then how can we find the functional value or polynomial interpolation? So that means when we are required to interpolate near the middle of the table of values, we need to obtain central difference interpolation formula for equally spaced values of x. In previous class, so we know that how to find the functional values at near the beginning of the table of values as well as at near the end of the table of values. So now in this class, we are going to find the functional values near the middle of the table of values. So for that, in previous classes through offline, you have seen that how to construct forward difference table, backward difference table, and central difference table. Apart from today's class, let me share the central difference table. Already we have discussed this one in offline classes. So how to construct the central difference table like that. So just let me recall this one. I am sharing the screen. Suppose x values are these, x0 plus h. So x0 is the middle of the x values. So how many x values are there? Infinitely many. So if x naught is the middle of the x values, the succeeding values of x are x naught plus h, x naught plus 2h, x naught plus 3h, and so on. And the preceding values of x naught are x naught minus h, x naught minus 2h, x naught minus 3h, and so on. So anyway, these are the x values. So according to these x values, the corresponding y values are at x naught, we have y value is y naught. At x naught plus h, we have y value is y1. At x naught plus 2h, y value is y2. And x naught plus 3h, y value is y3. At x naught minus h, y value is y minus 1. And x naught minus 2h, y is y minus 2, comma, and so on like that. Here x naught is the middle point and y naught is the central ordinate to x is equal to x naught. So according to these x values and these y values, we can construct the forward difference table like that, which we have seen in the previous classes through offline. So how to construct this one? First, to take the given x values. Here I am taking 7 x values. So x naught is the middle of the all x values. So first value is this, second, third, fourth value, fifth, sixth, seventh. And according to these 7 values, here I am taking x naught as the middle value of x. And the corresponding y values are here given values. Y minus 3 for this value, y minus 2 for this value, y minus 1 for this value, y naught for this value, y1 for this value, y2 for this value, y3 for x naught plus 3h value. So now these are the first and second columns are x values and y values, given tabular values. According to these given tabular values, we can go to find the forward differences, first order, second order, third order, and so on. So the first order differences are in this column like that. So y minus 2 minus y minus 3 is nothing but delta y minus 3. And y minus 1 minus y minus 2 is equal to delta y minus 2. Similarly, y naught minus y minus 1 value is delta y minus 1. And next, the difference y1 and y naught is delta y naught. y2 minus y1 is delta y1. y3 minus y2 is delta y2. And next, we go to take second order forward differences in this column like this. Delta y minus 2 minus delta y minus 3 is equal to delta square y minus. Similarly, the difference between these two is delta square y minus 2, and the difference between these two is delta square y minus 1. And similarly, delta square y is the difference between these two, and delta square y1 is the difference between these two. Now we go to take another order forward differences, third order forward differences in this column like this. So the difference between delta square y minus 2 and delta square y minus 3 is delta cube y minus 3. And then delta square y minus 1 minus delta square y minus 2 is equal to delta cube y minus 2. And similarly, we can follow this one. The difference between these two is this one, and the difference between these two is this one. And next we go for fourth order forward differences. These are like this in this column. And the difference between these two is delta power 4 y minus 3. The difference between these two is delta power 4 y minus 2. And the difference between these two is delta power 4 y minus 1. And similarly, we go to take fifth forward differences. Fifth order forward differences are in this column. That is delta power 4 y minus 2 minus delta power 4 y minus 3 is nothing but delta power 4 5 y minus 3. And similarly, the difference between these two is delta power 5 y minus 2. And the difference between these two is the next order, that is delta power 6 y minus 3. So this is the forward difference construction table according to the given tabular values like that. Here I am taking x naught as the middle value for x. So remember this table. So what is the middle value of x here? comma x naught. And according to this one, the corresponding y value is y naught. And now, so this is the central line. So this is the central middle value, so that this is the central line, which I am showing x naught, y naught, delta square y minus 1, delta to the power 4 y minus 2, delta to the power 6 y minus 3 is the central line in this table. Similarly, so this one, delta y minus 1, delta cube y minus 2, delta power 5 y minus 3. So these are the above central line. Okay, this is the central line. These are the above positions above of the central line. Similarly, delta y naught, delta cube y minus 1, delta to the power y minus 2. So this line is the, or these are the below the central line. So remember what is the central line. What are the positions on the central line? These are the entries on the central line. What are the entries above the central line? These are entries above the central line. And what are the entries below the central line? These are the this one, and this one. These are the below the central line. And so remember this table. This is useful for deriving the central differences formulas. Now, anyway, here we are talking about central differences. We know that central difference operator delta. This operator is forward difference operator, this delta. But we know that this delta is central difference operator. Now, we can convert these entries in this from this table. We can convert all these entries into the central difference operator like that by using the formula. One formula is there. Delta, forward difference operator delta is equal to central difference operator delta into shift operator e power 1 minus 2. So this also we have discussed in previous classes through offline. So anyway, we can convert the forward difference operator into the central difference operator. So then we can have the table like this according to the central difference operator. So x, y values are same. What are the entries in the first column? These are the entries in the first column. So according to this one, what are the entries in the first column? These are the entries in the first column. And suppose in the first column, so these x values are, y values are same. So in the first column, the first entry is delta y minus 5 by 2. And here in the first column, the first entry is delta y minus 3. Both the values of both entries are same. If you take any entry in respected column, so then that respected entry in that respected column is same. So remember these tables and the entries, the respected entries are same from the both the tables. Now we go to take how to derive central difference formulas. Apart from this, you are going to learn about Gauss's interpolation formulas, Stirling's interpolation formula, and Bezel's formula. So first we are going to discuss about Gauss's interpolation formulas. So in this, now we will discuss about Gauss's forward difference interpolation formula and Gauss's backward difference interpolation formula. So first I am going to give Gauss's forward difference interpolation formula. So here to derive this formula, we have to use Newton's forward difference interpolation formula, which we have derived in previous class. What is the Newton's forward difference interpolation formula? This one. Y is equal to y naught plus u delta y naught plus u minus 1 by 2 factorial delta square y naught plus and so on. If you see the previous class, this is the Newton's forward difference interpolation formula, where u is equal to x minus x naught by h. Now, here we are going to deriving Gauss's forward difference interpolation formula. This formula is useful for deriving this formula, Gauss's forward difference interpolation formula. So now for that, from the above table, which we have seen just now, from the table, delta cube y minus 1 is equal to delta square y naught minus delta square y minus 1. See delta cube y minus 1. Where is delta cube y minus 1? this one. So what delta cube y minus 1 is nothing but delta square y naught minus delta square y minus 1. From this table, we can take like this. Is it right? From the table, this one. Okay. Now, from this expression, we can write delta square y naught is equal to delta square y minus 1 plus delta cube y minus 1. And now from this expression, the further expression also we can write it as delta cube y naught is equal to delta cube y minus 1. Follow the same similar procedure. Delta to the power 4 y minus 1. And if we take another order, delta power 4 y naught is equal to delta power 4 y minus 1 plus delta to the power 5 y minus 1. Now, similarly, we can, from the table, we can take delta power 4 y minus 2 is equal to delta cube y minus 1 minus delta cube y minus 2. See, delta power 4 y minus 2. Here is delta power minus 2, this one. So what is this? Delta cube y minus 1 minus delta cube y minus 2. See here, take this expression like this. And now from this expression, we can have delta cube y minus 1 is equal to delta cube y minus 2 plus delta to the power 4 y minus 2. So similarly, if you follow the same expression for further order, that is delta power 4 y minus 1 is equal to delta to the power 4 y minus 2 plus delta to the power 5 y minus 2. Now, what are the expressions in this formula? Delta y, delta square y naught. The forward differences are here, delta y naught, delta y naught. Here, delta cube y naught will be there. And delta to the power 4 y naught plus and so on. So now, from this one, we got delta square y naught, delta cube y naught, delta power 4 y naught, and so on. Substituting all these values in our formula, then we get y naught plus u delta y naught. This is first term and second term as it is. And from the third term, what is the third term in the formula? U minus 1 by 2 factorial delta square y naught. What is delta square y naught? This one. So substitute this expression here. And what is delta cube y naught? This one. Substitute this expression at here. So after substituting all these values, the third term like this, the fourth term like this, the fifth term like this, and so on. Now you concentrate here, y naught. First term is as it is, and the second term will come as what is u? U can be written as answer. So here, let me recall that one formula, that is, what is that formula? Let me share this screen. For example, you know that the formula as NCR. What is NCR? N factorial by R factorial into N minus R factorial. Here, U is nothing but, in our formula, U is nothing but UC1. Okay, and now like that. What is UC1? This is N, this is R. U, N factorial, U factorial by 1 factorial into U N minus R, U minus 1 factorial. If you apply the same formula, that is U factorial can be written as U into U minus 1. For example, 6 factorial value is 6 into 5 into 4 into 2 into 1, like that. So U into the next preceding term is U minus 1 factorial by 1 factorial is 1, u minus 1 factorial. So both gets cancelled and the remaining term is u. So that u can be written as UC1. If you apply this formula, you can write u. So now this UC1 can be written as U1 like this. UC1 can be written as like this, UC1. So now let me show the same screen. So here, U is nothing but U1, and here this can be written as UC2. That means U2, and this meaning as UC3, that is U3, and this is same as plus this can be written as, this term can be written as U4, that is UC4. So if you simplify UC4, you can get this one. So that for our convenient, we can write this one as UC4. UC4 is nothing but U4. So this one factor is same as, and next plus and so on. Now the first term is as it is, the second term is as it is, and observe the second and third terms. So from the second term, we have U2 and delta square y minus 1, if you simplify this. And from the second term and from the third term, you can take common delta cube y minus 1. If you take common delta cube y minus 1 from this term and this term, you can get delta cube y minus 1 into U2 and plus U3, like this. And next you go to third term and fourth term and take common delta power 4y minus 1 from this term and this term. Then you can have U3 plus U4 into delta power 4y minus 1 plus and so on. You can follow the same. Now, if you observe that this one is nothing but UC1, this one is nothing but UC2. What about this one? We have some relation, that is U r minus 1 plus UR. So that means NCR minus 1 plus NCR nothing but. So this is equal to U plus 1R. This is one relation. If you apply this relation, we can convert this into the form U plus 1, 3. What is U? U is same as. What is R here? 3. This is 3 minus 1. That is R minus 1. So R here 3. So if you apply this relation to this one, we get U plus 1. R is 3, so that it comes 3. U plus 1, 3. Similarly, from this one, U plus 1, 4. From this one, U plus 1, 5. So the factor is same as, plus and so on. Now we are going to simplify this expression. So that is y naught plus U1 delta y naught plus U2 delta square y minus 1 plus U plus 1, 3 delta cube y minus 1 plus U plus 1, 4 delta to the power y minus 2 plus here you take common delta to the power 5 y minus 2 from both the terms. Then you get U plus 1, 4 from this one plus U plus 1, 5 from this one. So you get this term plus and so on. So next we go to, these terms are all same, and we convert this term, this expression by using this expression. So according to this one, we get this expression as U plus 2, 5, delta power 5, y plus minus 2 plus and so on. Now we can simplify this one. We know that UC1, that is UC2, U minus 1 by 2 factorial. U plus 1, 4, like that. So what if you apply NCR formula for this, UC1, UC2, U plus 1 C3, U plus 1 C4, U plus 2 C5. If you apply NCR formula for these, you can get this one U and U minus 1 by 2 factorial for this one, and U plus 1 U minus 1 by 3 factorial for this one, plus and so on. So if you have any doubt here, so I explained about this one, and if you go to take this one, I will give you U2 and U plus 1, 4. Just let me give that expression. For example, this one. Let me share the screen here. You know that U2, U plus 1, 4. What is U2? That means UC2. N, this is N, this is R, NCR, N factorial. U factorial by R factorial, that is 2 factorial. N minus R means U minus 2 factorial. So this is nothing but, what is U factorial? Simplify this one, U minus 1, U minus 2, U minus 3 and so on. So that we can restrict here, that is U minus 2 factorial, because 2 factorial into U minus 2 factorial is there in the denominator. So that both gets cancelled. The remaining part is U minus 1 by 2 factorial. So similarly, if you take this one, U plus 1 C4. So this is N, this is R. So n factorial, that is u plus 1 factorial by r factorial, that is 4 factorial into u plus 1, that is n minus r. R is 4 factorial. This is nothing but u plus 1 factorial by 4 factorial into, what is this, u minus 3 factorial. This is equal to, so now simplify this one. U plus 1 factorial is u plus 1. The next preceding is u. The next preceding value is u minus 1, u minus 2. So u minus 3. We can restrict up to here, u minus 3 factorial. 4 factorial into u minus 3 factorial. So this u minus 3 factorial, u minus 3 factorial get cancelled. And the remaining is u plus 1, u minus 1, u minus 2 by 4 factorial. So like that, we can simplify this one in the formula. So now let me share the formula. Let me share the screen like this. So what is u plus 1 C3, u plus 1 C4, like this. So now after getting this one, this formula is known as Gauss's forward difference interpolation formula. Now, if you observe this formula, in this formula, you can observe that all, what are these in this formula? Y naught is there, delta Y naught is there, delta square Y minus 1, delta cube Y minus 1, delta power 4 Y minus 2, like this. So Y naught, delta square Y minus 1, delta to the power 4 Y minus 2. And Y naught, delta, in the first term, Y naught is there. This one. In the second term, delta Y naught is there. Third term, what is delta square Y minus 1 is there. In the fourth term, delta cube Y minus 1 is there, like this. In the fifth term, delta power 4 Y minus 2 is there, like that. So anyway, these are all involving in the formula, forward differences. So now, if you observe that all odd order differences, odd order differences means this one. Differences lie just below the central line. So from the table, as we have seen that this is the central line. And these entries in the table are the below the central line. So in the formula, all odd order differences lie just below the central line, and even order differences are lie on the central line. So now in the formula which it is involving the forward differences, from the if you observe in the table, this is the central line and this is the below the central line. So this is the first term in the formula, this is the second term in the formula, this is the fourth term in the formula, this is in the fifth term in the formula, like this, like this, like this. So these entries are on the central line, these entries are below the central line. So our formula is involving these forward differences. So this is known as the Gauss's forward differences interpolation formula. And similarly, so this is in terms of forward differences. So we, from the both the tables, we can convert these forward differences into the central difference operator, like this. So if we can take, what is delta Y naught? Compare both delta, you can take place of delta Y naught, you can take delta Y minus 2. So if you compare both the tables, the position of the entries are same. So that observe this, where is this entry, in which position this entry in the forward difference table. The same, you can choose the another table, that is central difference operator table. So like that, you can change this one into the central difference operator. Now, when we use this formula to get better accuracy, when u lies between 0 and 1, then this formula is suitable for finding the better accurate value of the function value. According to this formula, I will give the example here. Suppose this is the forward difference interpolation formula for finding f of 3.75 from the following table of values. So these are the x value, these are the y values. How many x values are there? 6 values. So here, if we take 6 values, what is the center value? No. So there are 6 values. We can choose what is the middle value of x according to given value. So this is the given value for finding functional value. 3.75. If x is equal to 3.75, where it is? It lies between 3.5 and 4.0. So this is near the middle of the values. 3.75 is the middle or near the middle of the values. So that we can use this central difference formula, that is Gauss's forward difference interpolation formula. Now, according to this x 3.75, what is the h value from the x values? The difference between two consecutive values is 0.5. So the difference between two consecutive values are same, 0.5, that is h. Now we are going to find f of 3.75. We take the origin x naught equal 3.5. So we can choose as origin x naught 3.5 or 4.0 middle value. Okay, anyone we can choose. Here I am choosing x naught is equal 3.5. So now what is our x value? 3.75. At this value, we are going to do the problem. That means find the functional value f of x at this value. So anyway, x is equal to this one, x naught is equal to 3.5, h is equal to 0.5. Then we can find u value. So what is u from the formula? X minus x naught by h. X is 3.75 minus x naught is 3.5 by h 0.5. 0.25 by 0.5, that is 0.5. So observe here, u value is 0.5. It lies between 0 and 1. So if it lies between 0 and 1, definitely we can use Gauss forward difference interpolation formula. So now we go to use this formula. Thus, this is Gauss forward difference interpolation formula, which we have derived just now. Now, to apply this formula here, first we have to construct our relevant table for giving tabular values. So, from the table, values are 2.5, 3.0, 3.5, 4.0, 4.5, 5.0. And y values are, so from the problem, these are the y values. And take these y values in the table like this. And according to this x value, you can find u value. What is u? X minus x naught by h. X minus x naught. X naught is we have chosen here 3.5. H is here 0.5. So according to 2.5, u is minus 2. According to this x value 3.0, u value is minus 1. According to x is equal 3.5, u is 0. And according to x is equal to 4, u is equal to 1. And x is equal to 4.5, put in this one and you get u equal to 2. And if you take x is equal to 5 in this one, you can get u equal to 3. So anyway, according to these x values, u is equal to, these are u values. So in the third column, we are taking y values. So now, according to these x, y values, we can find the forward difference. First order forward differences, second order forward differences, third order differences, fourth order differences, and finally fifth order differences. There is no possible to get another order. Now, according to this, you know that how to construct the difference table. So this value is difference between both two. This value is this one minus this one. This value is this one minus this one. And you can get this value is this one minus this one. And this value minus this one is this one. And use the calculator to get all the values. So you can use it. Now, to get this column, that is second order forward differences. So this value minus this value is 0.284. Like that, you can get all the columns like this. So now after constructing the table for the given x and y values, you can substitute the relevant values in the table. So now you can compare this table into the general table, and then what are our values? Delta y naught, delta square y minus 1, delta cube y minus 1, delta power 4 y minus 2, delta power 5 y minus 2. Identify all the values in the table, and to identify this, you can choose the general table. So here x naught is 3.5 and y naught is 0. And this is the central line. This is the central line. Okay. So these are the entries on the central line. 3.5 x naught, 0 is y naught, and this is delta y naught like this. What is delta y naught? This is delta y naught. And this is delta square y minus 1. This is delta cube y minus 1. This is delta power 4 y minus 2. This is delta power 5 y minus 2. This is delta power 6 y minus 2, like this. So like that values we can have in the formula. Substitute all these values in the formula. Therefore, f of 3.7 x value is equal to, what is the formula? Y naught plus u. Our u is 0.5 into delta y naught. What is delta y naught? What is delta y naught? This one, minus 1.581 plus u into u minus 1 by 2. 0.5 into 0.5 minus 1 by 2 into next one, minus 0.237. So delta square y minus 1. Substituting all these values in this one. U plus 1, u minus 1 by 3 factorial into this value. And u plus 1, u minus 1, u minus 2 by 24 into this value. And then finally, we can have this one into this one. So now simplify all these values. The first term is as it is, second term is as it is, and you can write the third term like this. And simplify this one. 0.5 plus 1 is 1.5. 0.5 into 0.5 minus 1 is minus 0.5 by 6 into this one. Plus, so this one is 1.5. This one is 0.5. This one is minus 0.5. This one is minus 1.5 by 24 into this one. And next, this term. This value is 2.5, this value. This value is 1.5. This value is 0.5. This value is minus 0.5. This value is minus 1.5 by 120 into minus 0.003. Now simplify this one. 20.225 minus this one into this one is minus 0.7905 minus this. If you use the calculator and simplify this value, minus 0.0296 plus this value will come like this, 0.0024. This value will come like this, and this value will come minus 0. And totally simplify this value. Finally, you get the value is 19.4075. Where is 3.75? 3.75 is lies between 3.5 and 4.0. Here our u value is lies between 0 and 1. 0.5 is lies between 0 and 1. So definitely our functional value should also lie between 20.225 and 19.644. Our required functional value should be lies between these two values, because our x value is lies between these two. So what is our value? 19 point something. Definitely the 19 point something value lies between both the values. So this is accurate value. So this is our required value. So in like this manner, we can find the Gauss forward difference interpolation formula, and when we can use this formula, we have seen that. Now similarly, we can have Gauss's backward difference interpolation formula. So what is Gauss's backward difference interpolation formula? Say you can follow the same procedure as above, Gauss's forward difference interpolation formula. Here also, to derive this formula, we have to use Newton's forward difference interpolation formula. We know that this formula, Newton's forward interpolation formula, where u is equal to x minus x naught by h. Now, if you now we can from the table, as we have seen at the starting class, delta square y1 is delta y naught minus delta y minus 1. From this expression, delta y naught is equal delta y minus 1 plus delta square y minus 1. So now from this expression, we can follow the same procedure for further order. That is delta square y naught is equal to delta square y minus 1, delta cube y minus 1. And similarly, you can go to take another order, that is delta cube y naught equal to delta cube y minus 1, delta to the power 4 y minus 1. Next from the table, so you can go to take this expression to get this one. The same order is this, and here y naught is there, here y minus 1 is there. If you apply the same expression according to delta cube y minus 1, delta cube y naught equal to delta cube y minus 1. Delta cube y minus 1 equal to delta cube. What is next preceding value? Minus 1 is preceding value of 0. Okay, here the preceding value of minus 1 is minus 2. So this will come like this. Next value. And then what is this? Delta to the power 4. Cube is there. Okay, fourth order will come. And 0 is there, minus 1 is there. So minus 1 is preceding value of 0. The preceding value of minus 1 is minus 2. So y minus 2 will come. So like that, we can take another one by following this expression. So similarly, follow this expression to get another order, that is delta power 4 y minus 1 is equal to same delta cube, delta 4 will come. Minus 1 is there, minus 2 is there. So minus 1, minus 2 will come. So delta cube is there, delta 4 is there. Delta 4 is there, delta 5 will come. So y minus 1 is there, y minus 2 is there. Y minus 1 is there, so that y minus 2 will come. So like this. So after getting all these expressions, we can substitute these values in our formula. So what is the first term? Y naught. Second term, delta y naught. So substitute delta y naught. This expression substitute in this formula. Delta square y naught. Substitute this expression in this formula. And delta cube y naught. So substitute this expression in this formula and so on. So after substituting these values in the formula, we can get this one. Y naught plus u delta y naught, this one. And u minus y2 factorial delta square y naught value. And this one into delta cube y naught value, this one. So after substituting all these values in the formula, so we get this one. After getting this one, we are going to simplify this one. So as we have discussed in the earlier derivation, we can also follow the same procedure here. So first term is y naught, and see this expression. And u can be written as UC1. UC1 is nothing but UN. You can write like this. And this expression is same. Plus this is UC2. UC2 can be written as U2. And this expression is same. Plus this can be written as UC2 and U3. So you can write U3 and this expression is same. And this one is nothing but UC4. You can write UC4 like this. And this expression is same. Plus and so on. Now you are going to simplify this one. So how can we simplify this one? First term is this one. From the second term, delta y minus 1 is single term. You can write U1 delta y minus 1. And then you can observe this term delta square y minus 1. And from this term, delta square y minus 1 is there. So from both the terms, you can take common delta square y minus 1. If you take common delta square y minus 1, you can get U1 plus U2 like this. Okay. So now after the same, you can follow the same procedure. Delta cube y minus 1 is there. Delta cube y minus 1 is there. So take common delta cube y minus 1 from both the terms. Then you get U2 plus U3 into delta cube y minus 1 plus and so on. Thus follow the same procedure. So now as we discussed just now in the previous derivation, use this relation. Okay. So by using this relation, you can get first term as same, second term as same, third term can be written as by using this relation u plus 1. What is r here according to this relation? 2. U plus 1 2 delta square y minus 1 plus. So if you apply this relation, you can get this one as u plus 1 3. R is here 3. So the expression is here same. Delta cube y minus delta cube y minus 2 plus and so on. So here delta cube y minus 2. So now after this one, you can observe here delta power 4 u plus 1 delta u minus like this. So first expression is this, and then we get this expression. After that, we can get this expression by using this one. Now simplify this expression here, you can get this one. So after getting this expression, y naught u1 delta y1 u plus 1 to delta square y minus 1 plus this expression. From this one, you can take common delta power 4 y minus 2. This term is common from the both terms, this one and this one. So now you take common delta power 4 y minus 2, you can get u plus 1 3 plus u plus 1 4. So anyway, now you can convert this into single like this by using this relation. So all these terms are same, and this term can be converted into like u plus 2 4 like this. So u plus 1 4. So next you go to take another formula, that is you can written this one as u naught u1 u plus 1 c2 nothing but u plus 1 u by 2 factorial. This is same, and u plus 1 c3. You can if you can simplify this, you can write it as like this, and next this one can be written as like this. So now you go to take the same expression as this formula is nothing but Gauss's backward difference interpolation formula. So now observe this one. In this formula, the forward differences are delta y minus 1, delta square y minus 1, delta cube y minus 2, and so on. So that is y naught, delta y minus 1, delta square y minus 1, delta cube y minus 2, like this. Now, according to this one, all odd differences, okay, odd order differences are above the central line, and even order differences are on the central line. So if you observe the table, so this in this formula, the forward differences operators are on the central line and above the central line. In the previous derivation, that is Gauss's forward difference interpolation formula, so the terms, the forward difference operators are on the central line and below the central line. So if you see the table, once you can observe that the general table, central difference table like this. So this is the central line. These are the entries on the central line. These are the entries below the central line. So these terms are involving in the Gauss's forward formula. We have explained that. So in Gauss's backward difference interpolation formula, these terms are involving y naught, delta y minus 1, delta square y minus 1, delta cube y minus 2, like this. So that means on the central line, the entries which are above the central line. So anyway, this is related to Gauss's forward difference formula. This is related to the Gauss's backward difference formula. So remember the table and you can get easy to do the problems. So now here this is next where we are going to see this formula like this here. So this formula is Gauss's backward difference interpolation formula. Now similarly, we can convert these forward differences into central difference operator by using both the tables as we have seen. We can write in place of this one, you can write this one. In place of delta square y minus 1, you can write delta square y naught. Compare both the tables, same. You can take same entry. Then you can convert this one. So now when we use Gauss's backward difference interpolation formula, so when u value lies between -1 and 0, we can use this formula for getting better accuracy. So when u lies between 0 and 1, we can use Gauss's forward difference formula for getting better accuracy. Okay, this is the difference between both the formulas. Now I will give the example under this method, this formula. X values are like this, Y values are like this. X values are year 1941, 1951, 1961, 1971, 1981, 1991 to 2001. What is the difference between two consecutive values? 10. The interval of differencing is here 10. So now the population of the city in lakhs. In this year, 12 lakhs. In this year, 15 lakhs. In this year, 20 lakhs, like that. So anyway, these are the Y values. Population in the city in this year, respected years. So now, what is our problem here? Find the population of the city during 1966. Okay, 1966. Where is 1966? It is lies between 1961 and 1971. So 1966 lies between these two, 1961 and 71. So how many values are there? 1, 2, 3, 4, 5, 6, 7. So the center value is, middle value is 1971. Our 1966 value, X value is lies between this one. So our X value is 1966. Our X0 value, assuming this one as middle value, 1971. That is X0. So now H is 10. Now find U value. X, 1966 minus X0 is 1971 by 10. So now this value is minus 0.5. Minus 0.5 lies between minus 1 and 0. So that we can use Gauss's backward difference interpolation formula. So now what is that formula? So just above derivation, we can have this formula. Now, to apply this formula, first we have to construct the table for giving tabular values. So X values are like that, Y values are like that from the table. And find according to this X value, you can take U value like this. What is U? X minus X0 by H. So according to this X, U value is minus 3. Take X equal 1951 in this one. Then you can find U value minus 2 like this. So anyway, according to the given values, you can get the first order forward differences like that, second order forward differences like that, and finally, sixth order forward differences like that. So from this table, what is the middle value of X? So we assume that 1971 and Y0 is 0. So according to this middle value 1971, this is the central line 27, 5 minus 7, 25 is these are the entries or values on the central line. And in this formula, we are using the values which are above the central line. That is 1971, 0, 27 above the central line, 7, 3, minus 10. These are the values above central line. So that in this formula, we can have the formulas, this one X0, Y0, and this value. So what this value 27, delta Y minus 1. And this value, delta square Y minus 1. This one, delta cube Y minus 2. This value is delta 4Y minus 2. This one is delta power 5Y minus 3. This one is delta power 6, like that. So substituting all these values in the formula. So next, we get F of 1966. Our problem is X equal 1966. So at 1966, we have to find functional value F of 1966. So which is equal to substitute the values. So Y0. What is Y0? 27. This one, Y0 value. And my U. What is U? Minus 0.5. Delta Y minus 1. What is delta Y minus 1? This one, 7. Like this. And substitute all these values. U plus 1, U by 2 into another value, that is 5. Next value 3. Next value minus 7. Next value minus 10. Next value 20. Like this. So after substituting all the values, this U 0 minus 0.5, U plus 3, U plus 2, U plus 1, U minus 1, U minus 2, like that. So anyway, after getting all these, simplify this one. So now if we can simplify by using the calculator, you can have 27 minus 0.5 into 7, So this one, what is the third term here? This one. My 1 minus 0.5 is 0.5 minus 0.5 into 5 by 2, like this. And the third term is 0.5. This value is minus 0.5. This value is minus 1.5 into 3 by 6. And similarly, next term and next term. So next we go to simplify all the terms, we can get these values. And then finally, simplify this one, you can have the functional value at 1966, 22.8935. So now, what is 1966, where it is? 1966 is lies between 1961 and 71. And what is our U value? Lies between -1 and 0. So that definitely the Y value lies between 20 and it should be lies between 20 and 27. So what is our value here? 22 point something. So definitely it is in between 20 and 27. So our value is accurate value. So in 22 point something lakhs population in the year 1966. So this is the other problem according to the Gauss's interpolation formula. So from the above discussion, what will we have? That means when U lies between 0 and 1, we have to use Gauss forward interpolation formula. And remember other point, when U lies between -1 and 0, you can use the Gauss's backward difference interpolation formula. So if you follow like that, you can get the better accuracy. So when to find the functional value at any value of x, which is near the middle of the value. So in the same procedure, in the same concept, we go to take another formula, that is Stirling's formula. This formula is also useful for finding the functional value at any value of x, which is near the middle of the table. So when we use this formula, what is the purpose of this formula? The above both two formulas are needed. So to find the middle value, for interpolating at the near the middle values. But why are using this formula? So let me discuss about this one, why we are using this one for the middle values, for getting interpolation near the middle values. Okay. So that means first we have to derive this formula and later we go to take example. When we use this formula, I will discuss it. For example, we know that Gauss forward interpolation formula like this and Gauss backward difference interpolation formula like this from the previous discussion just now. But we have both the formulas. And now we take the average of two formulas to get the Stirling's formula. Stirling's interpolation formula is nothing but the average of two formulas, Gauss forward and backward interpolation formulas. So now, what is the average of these two formulas? Take the first term, that is as it is, plus U. Second term, delta Y0 plus delta Y1 by 2. So Y0 plus Y0 by 2, that is 2Y0 by 2, that is Y0. And from the second term, the average is this one plus this one by 2, that is U into this one, plus the third term is this one, and the third term in this formula is this one. The average of these two terms, that is this term plus this term by 2. So then you can get delta square y minus 1 into this u minus 1 by 2 factorial plus this u plus 1 into u by 2 factorial by 2. If you simplify both, you can get u square by 2 factorial. And then the next term, average of this one and this one. Take common delta cube y minus 2, delta cube y minus 1. So this term, entire term plus this term by 2 is nothing but the average of two terms. So if you average these two, this one plus this one by 2 like this, and then in this expression and this expression. simplify this one plus this one. You can get u into u square minus 1 by 3 factorial. And plus and so on. The next term will come the same. So if you follow this one, just only the average of two formulas is nothing but the Stirling's formula. So this is called Stirling's interpolation formula. Now you can observe that the differences are here. Y naught is there, delta y naught, delta y minus 1, delta square y minus 1. From this one, delta cube y minus 2, delta cube y minus 1. And from this one, delta power 4 y minus 2, and so on. So now y naught. So this is the average. This is the average of these two. And delta square y minus 1. So these two means average of these two third order differences. So if you observe in the table, general table, we can have these entries are on the central line. The odd differences, all odd differences are above the central line. All these different average of all odd differences are above the central line and below the central line. So if you observe the Stirling formula from the table, you can entries are like that. So the Stirling formula is in the Stirling formula, the differences are all like that. So x naught, this is y naught. These are the entries on the central line. These are the entries above the central line. These are the entries below the central line. So these are all are involving in the Stirling's formula, because these are only involving in the forward difference formula. These are only involving the Gauss's backward difference formula. The central difference formula is average of both the formulas. So that all these entries are involving in the Stirling's formula like that. So y naught plus the average, the second term is this one, average of this one, the third term involving this, the fourth term involving average of these two, and the fifth term involving this one, and the sixth term is involving this average of these two, and the seventh term is involving like this. So remember this table and identify this. So this is related to Gauss forward, and this is related to Gauss backward, and the total is related to Stirling's formula. Now we go to see the Stirling's formula. It is located at here, like this. So now when we use this formula, the concept is same for finding the functional value at any value of x. This is middle value of x, okay? But there is two formulas which we have discussed, Gauss's forward, Gauss's backward formulas. But why we are using Stirling's formula? Suppose if u lies between 0 and 1, we can use Gauss's forward for better accuracy. If u lies between minus 1 and 0, to get better accuracy, Gauss's backward is suitable. When u lies between minus 0.5 and 0.5, so this formula is useful for getting better accuracy, or for getting more better accuracy. When u lies between minus 0.25 and 0.25, we can use this formula for getting better accuracy. So now, according to this formula, we can take one example here. That is finding the functional value of x at x is equal to 28. For the given tabular values, what are the x values? 20, 25, 30, 35, 40. 5 values are there. And what is the middle value? X naught, 30. That is 30. So anyway, where is 28? 25. Like 28 lies between 25 and 30. So we can take 30 as the middle value. 28 lies between both two, 25 and 30. This 28 is nearer to the middle of the x values. So that x, we can choose x naught as 30. So these are corresponding y values. Now we can find the f of 28 values. So which formula is suitable? Let us check it. H is equal to 5. What is the interval of difference in 20, 25? What is the difference both? 5. What is the difference between these two 5? Anyway, interval of differencing is 5. And x naught is 30. We can choose it. And x is equal to our required value 28. So now u is equal to x minus x naught by h. Finding u value. X is 28, x naught is 30, and h is 5. Minus 2 by 5 minus 0.4. So what does 0? So it is not lies between 0 and 1. It is not lies between minus 1 and 0. Sorry, it is lies between which one? Which is lies between minus 0.5 and 0.5. Minus 0.5 and 0.5. So that we can use this formula to get better accuracy. So now apply the Stirling's formula, this one. Now you go to take construction of the table for giving tabular values. X values or Y values. According to these X values, find out U value. So X is equal to 20, take in this one, 20 minus 30 by 5, that is minus 2, like this. For this X value, 25, U value is minus 1. For X is equal to 30, U equal to 0. For X is equal to 35, U is equal to 1. For X is equal to 40, and U is equal to 2. These are the given Y values. Now, the first order forward differences are this value minus this one is minus 909. And similarly, this value minus this one is this one. And this the difference between these two is minus 1310. The difference between these two values are nothing but this value. Now, you go to take another order forward differences, that is delta square y. Now, the difference between these two values is minus 171. And similarly, that this value minus this value gives minus 230. And this value minus this value gives minus 310. Now, minus 230 minus of minus 171 is minus 59. Minus 310 minus of minus 230 is minus 80. So minus 80 minus 59 is minus 21. So this is the construction of the table. Now, so from this table, we can use relevant values to substitute in this formula. What are the relevant values? X naught is 30. That means Y naught is equal to 47, 23, 6. This is Y naught. So this is the central line. These are the values on the central line. So these are the values above the central line. These are the values below the central line. So these all values are involving in the Stirling's formula. So this is the first value, Y naught is this one. This the average. This is the average of both values. This value is this one. So this average of these two values is this one. And this is the next value, delta power 4, y minus 2 is there. Now, you can compare the original table and this problem in this table. You can get the suitable values. Now, substituting all these values in the formula. What is formula Y naught? Y naught is 47, 23, 6 plus U. What is U? Minus 0.4. And this is average of this one. So, minus 13110 minus 1080 by 2 plus U square by 2 factorial minus 0.4 by 2. Next value is delta square y minus 1 minus 230 plus U into U square minus 1 by 3 factorial. U is minus 0.4 and U square minus 0.4 whole square minus 1 by 3 factorial value is 6. And this is the average of these two values. Minus 80 minus 59 by 2 plus next value U square minus 1 by 4 factorial. So minus 0.4 whole square minus 0.4 whole square minus 1 by 4 factorial means 24 into delta to the power y2. That value is minus 21. And now simplify this expression. Okay. So what is the first expression? 47,236 plus, if we simplify this one, you can get this value. And then you can simplify the next term by using the calculator. You can get this value. And then this value gives 47,691.8256. So the value, our required value is this one. F of 28 is this one. So 47,691. So 47,691 F of 28. Where is 28? 28 lies between 25 and 30. So definitely the functional value lies between this value and this value, 47 and 48. What is this value? 47,000 for this one, 691. 691. So this value lies between like this. Okay. So definitely this value is accurate value. So now similarly, we can use Basel's interpolation formula for finding the functional value at any value of x which is nearer to the middle values. So how many formulas are there to find the functional value at middle values? Gauss's formulas, Stirling's formula, and Basel's formula. So from the Gauss's formula depends on u value. If you concentrate on u value, according to u value, you can choose which formula is suitable. So why we are choosing u value? So according to u value, if we can choose better formula to find the to get the relevant accuracy. So to get the required accuracy. So in that purpose, one more formula is there, that is Basal interpolation formula. This formula is nothing but here to derive this, we are using Gauss's forward interpolation formula. We know that Gauss's interpolation, forward interpolation formula is like this. Now, from the table, delta y naught is equal to y1 minus y1. From this expression, we can write y naught is equal to y1 minus delta y. Now, you can go to take y minus 1. So, use this expression to get y minus 1. So, y0 is there, y1 is there. 1 is succeeding value of 0. So, 0 minus 1, succeeding value of minus 1 is 0. Y naught will come. Y naught is there, delta y naught is there. Y minus 1 is there, delta y minus 1 will come. So if you follow the same expression for getting this one, so you can follow the same expression for getting this one. Now we can take delta square on both sides. We get delta square y minus 1 is equal to delta square y naught minus delta into delta square is delta cube y minus 1. Similarly, if you follow the same expression to get further order, that is delta to the power 4. So delta square. So delta square is there, delta square is there. If you take delta power 4 will come. So delta square is there, delta cube is there. So delta power 4 is there. According to this, delta power 5 will come. And now if you take y minus 1, y0 is there. For y minus 2, y minus 1 will come. Y minus 1 is there, y minus 1. So for y minus 2 is there according to this one. So if you now you can apply this, use these formulas in this formula. So to get the another formula, that is Basel's interpolation formula. So now if you take, what is this first one, y naught? What is y naught? Delta y naught. Y naught can be written as y naught by 2 plus y naught by 2. If you write like this, you will get y naught. So y naught can be written as like this. The value cannot be changed. And the second term is as it is. And if you take the third term, so anyway, if you take this one plus this one by 2, if you can write like this, the value cannot be changed. So this one plus the same value, this one plus divided by 2. So the value cannot be changed. So if you simplify this one, you will get this one only. So now you can write this one as it is. And the next term, you can write this one as this term plus again this term by 2. If we can write like that, the value cannot be changed, so that you can write that term plus that term divided by 2. So anyway, this formula can be rewritten as like this. Now using our conditions 1, 2, 3, 4. So what is 2? Why not? So now take the first term y0 by 2 plus take y0 by 2 as the second term, that is 1 by 2. Substitute y0 value here. What is y0? y1 minus delta y0, like this. Okay, plus next u delta y0 is there, so put as it is, plus next term you take this one 1 by 2 u minus 1 by 2 factorial delta square y minus 1. Take this term as it is, like this, plus change this term. Next term we have to change this one 1 by 2 u minus 1 by 2 factorial delta square y minus 1. Change it. What is delta square y minus 1? This one. Substitute this expression in this one. Next, what is the term here? 2 plus 1, this one, delta cube y minus 1, this one. Take as it is, plus, and then there are two terms. Take the first, this term as it is, like this, and change this term. So from this term, 1 by 2, and this one, and expression. Change this expression, delta power 4 y minus 2. That expression is this one. Substitute in this one. So like this. Okay, now after getting this one, we are going to simplify this one. So y0 plus y1 by 2. This one and this one can be written as y0 plus y1 by 2 plus, and then if you take delta y0 common from this term and this term, from this term u is there, from this term minus 1 by 2 is there. So u minus 1 by 2 into delta y0. So from these two terms, plus 1 by 2 u minus 1 by 2 factorial. If we take common these one from this term and this term, you will get this one into delta square y minus 1, delta square y0. So now if we take delta cube y minus 1, delta cube y minus 1. If we take common delta cube y minus 1, this one plus this one. Now you can get delta cube y minus 1, this one you can get like this. And then you can follow the same and you can get another term like this. Now, if you simplify this one, the first term is as it is, the second term is as it is, and what is the third term? U minus 1 by 2 factorial. So this expression by this 2. Plus, what is this? U minus 1 by 2 from this one. U into u minus 1 is there. And finally, the denominator value is 3 factorial into this expression. And from this one, u plus 1, u minus 1, u minus 2 by 4 factorial, and this expression by this 2, this one. So this is the Basel's interpolation formula. So now if you observe this one, the Basel's interpolation formula, it is involving, this is the average of y0 and y1. And the second term is delta y0. So the third term is involving average of delta square y minus 1, delta square y0. And this next term is delta cube y1. The next term is average of these two, delta power 4 y minus 2, delta power 4 y minus 1. So from the starting table, you can observe that these are on the central line. These values are below the central line. These are also below the central line. So anyway, odd differences, these are in the formula. Odd differences are below the central line, and the even differences are on the central line and below the central line. When we use this formula to get the interpolating value near the middle values, if u is lies between 0 and 1, or u lies between 0.25 less than or equal to u less than or equal to 0.75. So if u satisfies this condition, you can use this formula for getting better accuracy. If u satisfies this one, you can use this formula. Already, if u lies between 0 and 1, we said that the better formula is Gauss's forward interpolation formula. in that case, for getting more better accuracy, if u lies between like this, you can use this formula. Okay. So according to this one, if you take example and you can do the same problem. Take the problem and construct the table and find the x values or y values, u value and forward differences from the table, and the substituting relevant values in the formula, and then you get the after simplification you get the required value. So now according to this example, x values are 20, 24, 28, 32. Y values are this value and 3162 and 3544 and 3992. So where is 25? 25 lies between the x value 24 and 28. So definitely the functional value lies between 3162 and 3554. And where is 25? It is near the middle of the value. This one. Here I am taking x naught as the middle value like this. Okay. Now, according to this one, substitute all the values and then you can get it. What is u value from this one? 0.25. So 0.25 lies between 0 and 1. Here also we can use Gauss's forward difference formula. But 0.25 is satisfies this condition. U lies between 0.25 and 0.75 and u is equal to 0.25 or 0.75. If satisfies this condition, or say 0.25 satisfies this condition and this condition, you can use, according to this one, you can use Gauss forward difference interpolation formula. According to this one, you can use Basel's interpolation formula. So if you use Basel's interpolation formula at this case, you can get more better accuracy than using the Gauss forward interpolation formula. So that is the only the difference. The example is same thing. So this is the till now we have completed the for Newton's forward backward interpolation formulas and Gauss's forward backward interpolation formulas and Stirling's formula and Basal interpolation formula. Tell me, ma. So when we use Gauss's forward interpolation formula, backward interpolation formula, ma, when we can use?
Middle term. Middle of the point, ma'am.
Okay, middle of the point to find the functional value, which is at any value of x, which is nearer to the middle value. Okay, ma. But there are two cases, forward and backward. So when we use forward formula and when we use backward formula, Gauss's near the middle values only. When we, what is the difference between both? You concentrate on u value, ma. If u lies between 0 and 1, you go to use Gauss's forward. If u lies between -1 and 0, you go to use Gauss's backward formula. Next, what is the purpose of Stirling's formula and Basel's formula, ma? The concept is same. Here also finding the interpolating near the middle of the values. Content is same. But when, how can we use and when can we use Stirling's and Basel's formula? If u lies between
-0.5 and 0.5.
Yeah.
Stirling's formula.
Okay, what Basel's formula? If u lies between 0 and 1 or
0.75.
Closed bracket of 0.25 and 0.75. So if you in closed bracket 0.25 and 0.75, you go to apply the new Basel's interpolation formula. This is for gives better accuracy. That means better result. Okay, ma. Thank you.
Thank you, ma'am.